Hello, welcome to this video. Today, I will be introducing one of the core modules I teach at the National Polytechnic School of Algiers, titled Point Mechanics. This module is an essential part of our curriculum, designed to provide first-year students with a strong foundation in the principles of mechanics. Over the course of this module, we will explore fundamental concepts that form the backbone of various scientific and engineering disciplines, helping students to develop a deep understanding of how forces and motion operate in physical systems. Whether you're new to the subject or looking to deepen your knowledge, I hope this video will serve as a valuable guide to the exciting world of point mechanics. In this video, we will take a closer look at the point mechanics module, outlining its key concepts, objectives, and the essential topics it covers. Throughout the course, you'll be introduced to fundamental principles that are critical to understanding the behavior of particles and the forces acting on them. Whether you're completely new to the subject or seeking to deepen your understanding, this video will serve as a comprehensive guide through the key aspects of the point mechanics module. We will walk you through the structure of the course, providing a clear roadmap of the topics you'll encounter, along with insights into the concepts you'll be mastering. By the end, you'll have a solid grasp of what lies ahead and the tools needed to succeed in your studies. Point mechanics is a fundamental discipline that bridges both mathematics and physics. It forms the backbone of our understanding of matter, introducing the core principles that govern the motion of particles and bodies. This module delves into crucial topics, including the dynamics of particles, the examination of common forces, and the mathematical techniques used to determine object positioning and movement. Additionally, it explores the field of kinematics, which describes the motion of objects without considering the forces that cause that motion. One of the focal points of point mechanics is the study of objects with minimal spatial extension, often referred to as point particles. These objects are treated as if their size and shape are negligible, allowing us to focus on the forces acting upon them without accounting for their deformations or rotational energy. Interestingly, even massive objects like the Earth or the Sun can sometimes be simplified as point particles when we study their interactions with other bodies, depending on the scale and context of the analysis. This course is divided into 5 chapters. Chapter 1, Vector Calculus and Mathematical Fundamentals. Chapter 2, Kinematics of a Particle. Chapter 3, Relative Motion. Chapter 4, Dynamics of a Particle. Chapter 5, Work, Power, and Energy. Each chapter includes detailed exercises and solutions to reinforce the concepts covered. By the end of this module, we aim to provide first-year students with a solid understanding of point mechanics. In this video, we will focus on Chapter 4, which deals with the dynamics of a particle. This chapter introduces the fundamental laws of dynamics, a core aspect of classical mechanics. Dynamics studies how forces influence the motion of bodies. The laws of Newton, which apply in inertial, Galilean frames of reference, and when body speeds are much lower than the speed of light, include Newton's first law of inertia. In an inertial frame, a free body remains in uniform rectilinear motion or at rest unless acted upon by an external force. Newton's second law, Fundamental principle of dynamics. The change in momentum of a system is proportional to the force applied to it. The rate of change in momentum produces the applied force. Newton's third law, action and reaction law. For every action, there is an equal and opposite reaction. When two bodies interact, the forces they exert on each other are equal in magnitude and opposite in direction. Gravitational interaction, fourth law. Newton's laws also describe gravitational interaction. Any particle m1 attracts another particle m2 with a force along the line connecting them. The gravitational force is defined by F equals g multiplied by m1 multiplied by m2 divided by r squared, where F is the force between the particles, r is the distance between the particles, g is the gravitational constant equal to 6.672 times 10 to the power of -11 in Newton meters squared per kilogram squared. This chapter spans 4 weeks of teaching. At the end of the chapter, students will take an individual assessment to test their understanding. The passing grade for this course is 10 out of 20 or higher. This brings us to the end of this video. Thank you for your time and attention throughout the presentation. I hope the content has been insightful and has helped clarify the key concepts of the module. I look forward to seeing you again in the next video, where we'll continue to explore more exciting and fundamental topics. Until then, take care and keep pushing forward in your studies